So students, we have come to the end of phase rule. This is the fourth system, students. First one we have learned under one component system as water system. Later we have started two component system, under which the first one silver lead, and last week we have learned magnesium zinc system, and today this is the third one under two component system. Okay, so we have four major questions in the chapter phase rule, students. Okay, so all four are important as I have told you earlier also. Okay, so this is third one under two component system, students. Put the side heading salt water system. Today is the last class of phase rule. Fine. Okay, so put the side heading salt water system. Fine. Now the possible phases under this system are solid ice, solid sodium chloride, solid NaCl, 2H2O, and solution. Kindly write down the possible phases under this system: solid ice, solid NaCl, NaCl, 2H2O plus solution. Okay, so NaCl, 2H2O is the new compound, that is sodium chloride dihydrate is the solid phase forming from salt and water, students. Okay, so this is the new phase in this system, and the fourth one is solution of salt and water. Okay, so next this is the phase diagram of salt water system, and the two factors taken into consideration: temperature on y-axis and composition on x-axis. Okay, so we started with the water, and by the time we reach there, water becomes 0% and 0% NaCl we are starting. As we move from here to that side, NaCl composite amount will be increasing. Okay, so draw this diagram carefully, students, with take a scale, pencil, eraser, and here mark the point as E and mark the temperature 0 degrees centigrade, and here mark this point as O. Okay, and temperature corresponding to point O minus 21 degrees centigrade, and mark this point as B, 0.15 degrees centigrade. Okay, so this is BC curve, students. OB, AO. Fine. Here write down this area as unsaturated solution. Here ice plus solution. Along this curve NaCl, 2H2O plus solution. Along BC curve anhydrous NaCl plus solution. Okay, and corresponding to O, the percentage of NaCl 23%. Rest of the percent is water. Okay, so mention all the points and write down all the phases carefully, students. So whichever system we take, students, in all the four systems, diagram is very important. Okay, so first learn the diagram. So if you know the diagram, writing down the points is easy. Looking at the diagram, you can write down what are the curves, what are the phases existing in equilibrium along the curves, what is the eclectic point, okay, what is the triple point, and what are the phases existing in equilibrium at the triple point or eclectic point. So whatever is the system, first be confident with the phase diagram. Writing down the points below the diagram is very easy. First, don't write the points and then draw the diagram. Okay, when it is asked in the exam, first be ready with the phase diagram. So, completed students? Fine. Now, are you ready to learn about the curves and the points, temperatures, composition, everything? Ready, students? Fine. So, students, first put the side heading. So, what are the curves that you are observing in this diagram, students? AO curve, OB and BC curve. Okay. And point O, we call it as eutectic point. And point B is, what is it, students? Incongruent melting point of the new compound, that is NaCl2H2O. You know the meaning of congruent melting point and incongruent melting point. Okay. So, we will learn one after the other. So, first put the side heading AO curve. Fine? Right. So, what is this curve called as? What is the other name of this curve, students? AO curve. It is called as freezing point curve of water or melting point curve of ice. Write down. This curve is also called as freezing point curve of water or melting point curve of ice. Both will be the same, students. Fine. Now, so what is the temperature at point A? 0 degrees. It is melting point of ice or freezing point of water. Fine. Now, this is coming down, that is AO curve. So, temperature O is coming down. That means it changes into minus value. So, why is it coming down? See, we started with 100% water, and as we are moving from here to right side, we are adding NaCl slowly to water. Okay. So, addition of NaCl to water, what is it doing? The freezing point is slowly coming down, students. Okay. So, that's what I mentioned here. AO curve represents lowering of freezing point on addition of NaCl. Okay. So, what is happening? The freezing point from 0, it's coming down slowly on addition of NaCl. So, when you are still adding NaCl, that means when you are adding more and more NaCl to water, what is happening? The temperature is also coming down more and more until point O is reached. Okay. At point O, a new phase will be formed that we will discuss in the next point, students. Okay. So, what you will write here? AO curve represents lowering of a freezing point on addition of NaCl. Okay. Next point, write down. When more and more NaCl is being added, what happens? Freezing point is also decreased more and more until point O is reached. Okay, understood, students? And along this curve, what are the two phases existing in equilibrium? Ice and the solution of salt and water. Okay, so mention that one. Along this curve, two phases, that is ice and solution, exist in equilibrium with one another, and hence from reduced phase rule expression. What is reduced phase rule expression? F is equal to C minus P plus 1. Okay. So, how many components, students? Two components. What are they? Salt and water. Okay. So, how many phases? Ice and solution. 2 minus 2 plus 1, it is equal to 1. So, it has 1 degree of freedom. What is it? What does it mean? Either temperature or composition can be changed so that the phases existing in equilibrium will not be disturbed. So, when F is equal to 1, we call it as monovariant or univariant. Therefore, AO curve we call it as, or we can describe it as univariant or monovariant, students. Okay. So, these are all the points about curve AO. Next, point O. Okay. So, this point is also called as, students, eutectic or CryoHybrid point. Okay. So when point O is reached, what happens, you know, students? The NaCl and water, they combine to form a new solid, that is NaCl2H2O. What do we call it as? It is called as sodium chloride dihydrate. Okay. So by the time point O is reached, this new phase, it starts separating out from the solution. Okay. So write down at point O, a new solid phase NaCl2H2O starts separating out. Okay? NaCl2H2O starts separating out. Full stop. And this is called as eutectic or cryohydric point. This is called as eutectic or cryohydric point. And as we all know, the significance about these points in the phase diagrams, all the three phases will be existing in equilibrium with one another. What are the three phases, students? Ice, solution of salt and water, and the new compound, that is NaCl2H2O. Right now, at this point, three phases, that is ice, solution and NaCl2H2O exist in equilibrium with one another. Okay. Now, from reduced phase rule expression, F is equal to C minus P plus 1. It is equal to 2 components, 2 minus 3 phases, 2 minus 3 plus 1. So, it comes equal to 0. What does it mean, students? F0 means it is invariant or non-variant. It is defined by itself. See, look here. Point O corresponds to 23% NaCl, a fixed composition, students. Rest of the amount is water, and it corresponds to temperature minus 21 degrees centigrade. So this point corresponds to one single temperature and one single composition. If you try to change minus 21 or 23% NaCl, that composition or temperature, if you try to change it, that equilibrium will be disturbed. We cannot find all the three phases existing in equilibrium with one another. Okay. Therefore, you can write down it is defined by itself. That is, it has one composition, 23% NaCl and one temperature minus 21 degrees centigrade. Okay, students, this is all about point O, which is called as eutectic or cryohydric point. And also, students, the compound forming at point O, that is NaCl2H2O, it is not exactly a perfect solid. We call it as a cryohydrate. Okay, that's why immediately what happens, by the time it reaches its melting point, it gets decomposed. It separates into water and anhydrous HCl. Okay, next is, students, OB curve, not BO curve. Okay, try to understand. AO coming down, OB going up. Okay, put the side heading OB curve, which can also be called as the curve of dihydrate. Why? Because at point O, what is being formed, students? The new solid phase NaCl2H2O, that is sodium chloride dihydrate. Okay, so hence it is also named as curve of dihydrate. So what do we learn from this OB curve, students? So what did we learn about AO curve? When we are adding NaCl, what happens? Slowly freezing point has come down. Now we are continuing the addition of NaCl. So on further addition of NaCl, what happens? NaCl2H2O, what happens, students? The freezing point slowly increases along this curve OB on further addition of NaCl. Okay, so previously there was only water. So on addition of water, what happened? On addition of NaCl, what happened? Freezing point has come down. So by the time point O is reached, what happened? NaCl2H2O is formed, right? So what are we doing? We are adding NaCl. We are moving that side, means we are continuing the addition of NaCl. Okay, so on this addition of NaCl, more and more as we are adding, freezing point slowly goes up along the curve OB. Okay, so that's what write down students. First point under this, it's also called as curve of dihydrate, and the next point, freezing point increases along OB curve on further addition of NaCl. Okay students, next this point B. Okay, what is the temperature corresponding to point B? It is 0.15 degrees centigrade. As I told you earlier, this point B is called as the incongruent melting point of the new solid phase. Okay, so write down point B is called as incongruent melting point. In brackets, mention the temperature 0.15 degrees centigrade. Okay. What is the meaning of incongruent melting point, students? It decomposes into anhydrous NaCl and water. What's the meaning of anhydrous NaCl? Without water, we call it as anhydrous NaCl. Okay. So point B is called as incongruent melting point. In brackets 0.15 degrees centigrade, where it changes to anhydrous NaCl and water. Clear now till here? Next, along this curve, again there are two phases. What are they? The new solid phase and the solution are in equilibrium with one another. NaCl2H2O is in equilibrium with the solution. Same from phase rule, reduced phase rule expression. F is equal to C minus P plus 1. So it is equal to 2 plus 1, which is equal to 1. Again, this OB curve is invariant as it has only 1 degree of freedom, students. Okay, so write down all these points under OB curve. Next is, what is remaining, students? We have learned about AO, OB, and one more curve is there, that is BC curve. Put the side heading, BC curve. Okay, now what is it called as? It is called as solubility curve of anhydrous NaCl. So at point B, it is separated, students. Now it is not in the form of NaCl2H2O. It's being separated into anhydrous NaCl and water or solution. Okay, now look here, this is called as solubility curve of anhydrous NaCl, and along this curve you can find out two phases in equilibrium, anhydrous NaCl and solution. So again, if you calculate degrees of freedom, we get it as 1, which means that univariant. Okay students, so here you need not describe about the areas and all, just the important portion, the important here is to mention about the curves of salt water system. Okay students, we have learned about AO curve, OB curve, BC curve and also point O. Fine? Understood now? So next is students, freezing mixtures. This comes under salt water system only. Okay, you should write under this answer only, students. Fine. So put the side heading, freezing mixtures. Freezing mixture. Ready? Now, suppose students, take an ice cube. Take one plain glass of water, one glass of plain water, add this ice cube into that glass of water. What do you observe, students? If I ask you the question, the first answer which you give is ice starts melting. So now when this ice starts melting, what happens to this water? We have taken plain water, it's not cooling water, okay? Now when you added this ice, it slowly starts melting and the glass of water starts cooling. That means we say that the temperature of water slowly comes down. That means it is being reduced. Okay. Now to this water in which you have added an ice cube, if you start adding salt slowly, what happens? The salt gets dissolved, starts dissolving slowly. Okay students, what did we do? We have taken a glass full of plain water, one ice cube, and slowly we are adding salt to this glass of water. Okay, so salt, what it does, it gets slowly dissolved in water, even if you don't stir it with a spoon or spatula. Okay, that you all know, right? Now at one stage stage or at one temperature, what happens, students? This salt, ice and solution, all these three phases, they are in equilibrium with one another at one particular temperature. That temperature at which this ice, salt and solution are in equilibrium with one another, we call it as a eutectic or cryohydrate temperature. Okay, so different salts in contact with ice will have different temperatures. NaCl in contact with ice, what is the temperature, students? Minus 21 degrees centigrade. Like this, different salts in contact with ice will be having different temperatures. Okay, so write down all these points under freezing mixture, students. I am reading out for you. Addition of water to ice. Addition of water to ice or addition of ice to water, anything you can write, lowers the temperature of water. Okay, so I will change it. Addition of ice to water lowers the temperature of water, and when salt is added slowly, in small amounts, it dissolves in water. And at one stage, ice, solution and salt exist in equilibrium with one another. Okay, and this temperature is called as, this temperature or the temperature at this point is called as eutectic or cryohydrate temperature. Eutectic or cryohydrate temperature. Full stop. Below write down. Mixtures of ice and salt. Mixtures of ice and salt are called as freezing mixtures. Full stop. Different salts in contact with ice have different temperatures. Okay, so let us note down few examples of few salts in contact with ice, students. So students, write down the system and the temperatures. System is the salt in contact with ice. Okay, so first one I have given the example, NH4Cl plus ice, ammonium chloride plus ice, minus 16 degrees centigrade. Next, NH4NO3 plus ice, minus 18 degrees centigrade. Next, NaNO3 plus ice, minus 18.1 degrees centigrade. Next, NaCl2H2O plus ice, minus 21 degrees centigrade. Ki plus ice, minus 23 degrees centigrade. Next, CaCl2 plus 6H2O plus ice, minus 55.9 degrees centigrade. So when asked in exam, you need not write all these examples. Along with NaCl2H2 plus ice, one or two you can write. Okay, you need not write all these examples in the exam. Okay students, draw a line till here. So till here is the answer for salt water system. So with this we have completed all the three systems under two component system along with one component water system. All the four systems we have completed. So we have reached almost the last portion of phase rule. There are few numericals, students, not exactly mathematical calculations. There are few numericals in this chapter. Let us do the numericals in this chapter, that is phase rule. Put the side heading numericals. Okay students, ready? So write down students, give the number of phases, number of components and calculate degrees of freedom for the following equilibria. So what are we supposed to do, ma? We should give the number of phases, number of components. So if we have number of phases and number of components, we can calculate degrees of freedom. Okay. Write number 1. An aqueous solution of a salt in equilibrium with vapor. An aqueous solution of a salt in equilibrium with vapor. Okay. So this is the equilibrium. We should write down the number of phases, number of components. So number of phases anyhow I have directly given. That is salt solution in equilibrium with vapor. So number of phases will be 2 students. Number of components also will be 2. What are the 2 components? See, it is the salt solution, completely dissolved, aqueous solution of salt. That means one component is of salt and the other is of water. Okay. So there are 2 components in this equilibrium. One is of salt and the other is of water. So we have 2 phases, 2 components. Next, from these 2 we can calculate degrees of freedom. So write down F is equal to C minus P plus 2. It is equal to number of components 2, number of phases 2. 2 minus 2 plus 2 is equal to 2. This equilibrium is bivariant. Okay. So these are just numericals, students. Fine. Second one, second equilibrium. Solid benzene in equilibrium with liquid benzene. Solid benzene in equilibrium with liquid benzene. Which phase is absent? Vapor phase is absent. I did not do the solution. You can do it on your own. 2 phases, solid and liquid. How many components? 1 component, that is benzene. Okay. So you should use reduced phase rule expression. F dash is equal to C minus P plus 1 or F is equal to C minus P plus 1. So substitute the number of components as 1, number of phases as 2 and you can calculate degrees of freedom. Fine, students. So this is the way how we get numericals based on phase rule, that is calculation of components, phases and degrees of freedom. Okay. So enjoyed this chapter, students. Hope I made all the systems and each and every topic in this unit clear and easy. Okay. So this is all, students, about phase rule. We have completed the unit phase rule. Now it is your turn to prepare for your exam. Okay. So write down all the points. Don't miss any point. Okay, students. Thank you.